dear. Today I am talking about differentiation. What is differentiation? At first we define and what is its using in applied field of mathematics. This is the very important topic for applied mathematics. It is one part of the calculus and it was discovered by Leibniz. Someone say Newton was discovered, but it was the necessity for Newton. But Leibniz has more discovered about this topic. So now I am going to talking about differentiation. We can also say derivative of a function, differential coefficient of a function. So we can say dc of a function or differentiate any function or derivative of a function. Here before I have said about in limits there is 2 points. One is left hand limit and one is right hand limit. Here differentiation we have find the value of left hand derivative and right hand derivative. Derivative of a function f of x. It is denoted as f dash x or d by dx of f of x or capital D fx, or sometime if we write y for fx then y1. This is nothing but this is the first derivative f dash x or d by dx of f of x or dfx or y1. These all are the first derivative of a function fx. Left hand derivative L f dash x, this equal to limit delta x tends to 0 f of x minus delta x minus f of x divided by difference of this, that is minus delta x, where delta x is the sum increment in x. And right hand derivative r f dash x is limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. If this function f of x be differentiable or derivable when left hand derivative equal to right hand derivative. This is nothing but left hand derivative and this is right hand derivative. This is also defined as d by dx of f of x. This is when its geometrical meaning is limit delta x tends to 0 delta y by delta x or limit delta x tends to 0 del f of x y dx. This d by dx is an operator. In addition, subtraction, multiplication we denote it as plus, minus, into, like that. Here for differentiation d by dx is an operator which defined as differentiating this function with respect to x. We can also differentiate another variable. So this is the first derivative. If we have given y is f of x, then we can also write as y1 is f dash x, y2 is nothing but second derivative. This is f double dash x, or we can also write d by dx of f dash x, and this is d by dx of f of x. D by dx f dash x, here f dash x is d by dx of f of x. So d by dx of d by dx, and we can write as d2 by dx square of f of x. This is the second derivative, and similarly we can find third derivative, fourth derivative, and nth derivative. One also, its geometrical meaning d, when limit delta x tends to 0, delta y by delta x is nothing but dy by dx. This is dy by dx, and it represents the slope of the curve. Its geometrical meaning is slope of the curve y. Now I am going to discuss about the differential coefficient of a function. How can we find the differential coefficient of sin x, cos x, tan x, and this is also known as first principle method. If we have find here given, find the DC, that is the differential coefficient of sin x. Let f of x is sin x, therefore f of x plus delta x is sin x plus delta x. Here delta x is the sum increment in x. By the definition of the derivative d by dx of f of x, this equal to limit delta x tends to 0. We can write left hand derivative or right hand derivative. F of x plus delta x minus f of x divided by delta x. Limit delta x tends to 0, sin x plus delta x minus sin x by delta x. Limit delta x tends to 0. Here sin c minus sin d, we can use formula sin c minus sin d. 2 cos c plus d by 2, 2x plus delta x by 2 into sin c minus d delta x by 2 divided by delta x. Limit delta x tends to 0, 2 cos x plus delta x by 2 sin delta x by 2 by delta x by 2 into 2. Here we are just as sin theta by theta. 2 cancel. Now using limit delta x tends to 0, cos x plus delta x by 2, limit delta x tends to 0, sin delta x by 2 by delta x by 2, and this is d by dx of f of x, or we can also write f dash x. Here cos x plus 0 into 1, this is cos x. Hence d by dx of sin x, this equal to cos x. The DC of sin x, differential coefficient of sin x, is cos x with respect to x. Here differential coefficient of sin x with respect to x. Similarly, we can find cos x, tan x, e raised to x, and we have to use the limit formula. One important things I am going to discuss: if a function is differentiable, then it will be continuous. This is the necessary condition. If any function is differentiable, then it must be continuous. But if a function is continuous, then it may be differentiable. Here we have seen left hand derivative is limit delta x tends to 0, f of x minus delta x minus f of x divided by minus delta x, and right hand derivative is limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. If fx is differentiable, then left hand derivative equal to right hand derivative, and this implies limit delta x tends to 0, f of x minus delta x minus f of x divided by minus delta x equal to limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x, and this delta x cancel. We can write limit delta x tends to 0 minus f of x minus delta x, limit delta x tends to 0, f of x, and right side limit delta x tends to 0, f of x plus delta x minus limit delta x tends to 0, f of x, and this implies we can write f of x, this is independent of delta x, so we can write f of x minus limit delta x tends to 0, f of x minus delta x, in this equal to limit delta x tends to 0, f of x plus delta x minus f of x. And this is possible when limit delta x tends to 0, f of x minus delta x, this equal to limit delta x tends to 0, f of x plus delta x, and this equal to f of x. If we take this two part, we get here from limit delta x tends to 0, f of x minus delta x equal to f of x, and we find this result. From this two result, limit delta x tends to 0, f of x plus delta x equal to f of x, we get this result. We take left side, this will be limit delta x tends to 0, f of x plus delta x minus f of x, and here we take from this two result, we take right side f of x minus limit delta x tends to 0, f of x minus delta x, and these all are equal when function f of x is continuous. So this is possible only when f of x is continuous. So we get, hence, if fx be differentiable, then fx be continuous. This is the necessary condition. But converse may be, if a function is continuous, it may be differentiable. Okay, thank you.